to cover. We're going to talk about. Okay, I just want to clear this dialogue on my way for a second. Sorry. We're going to talk about it. What do we mean when we talk about pattern matching? What do we mean when we talk about decomposition? Because they're related ideas, but they're not exactly the same. And then how do we do pattern matching in various functional languages? To me, this kind of I don't know if I'm pronouncing the word right. It's like if you look at Rosetta Code, it's like a programming crestophony or something like this. It's kind of comparing how you do things in different languages. And to me, that's always an interesting topic because it helps you to figure out what's really, it's got to be there, and what's like, oh, this is the language designer's choice. So what we're going to do, I'm going to show you a small, simple problem in functional, and then I'll show you how we do it in like 4 languages. And I got another problem. I got a couple languages to demonstrate, but I didn't want to like plan out too much because I like to hear other people talk. I like to hear questions and stuff like that. So, first of all, what is pattern matching? In order to give us a notion of what the term means, or break it down into subterms, when we say pattern matching and decomposition, we're going to talk about pattern matching first and then decomposition, so we get a feel for what do we mean by this. So if you think about a pattern, like you might look at a series of numbers and say, okay, if I multiply this by 2, then I get this other thing, and that's a pattern, right? Human beings are wired to notice patterns in things, right? So it's kind of a template of something we're interested in. You might be interested in matching like a pattern of a list. And when I say list in functional programming, I almost always mean linked list. That's pretty much a given in almost any functional language you're talking about. It's a linked list. But let's say I were interested in matching a pattern of a list of 3 elements. I don't care what the elements are. I just want to know that's a list of 3 elements. There's a way to do that with pattern matching. The matching part means we basically, here's the template, here's the pattern we're looking for. Does it conform to this data that we're looking at? Does it conform to this pattern? That's the matching part. So we get like basically, we don't have necessarily a predicate we can check, but what we get is we get back a Boolean. Either it's true or it isn't. Either it's matching or it isn't. So pattern matching is a built-in facility in a lot of programming languages, not just functional languages, but a lot of programming languages use it to determine if a particular piece of data conforms to a specified pattern. Okay, it's very similar to the notion of regular expressions. If you're familiar with regular expressions, it's very much along the same lines. So what do we mean by decomposition? To me, it may not be good practice, but I can't define decomposition without defining it in terms of what is composition. Composition is putting things together, right? It's like I take and I put together this one element and this other element and this other element, and I make it into a larger thing, right? Decomposition is the opposite process. I take a larger thing and I break it into smaller pieces, right? So when we talk about decomposition, what we're talking about is here's a pattern of data, right? For instance, we're going back to that original, the example I was showing you just a second ago. I have a list of 3 things. I want to decompose my list into those 3 things. So decomposition means I take and I bind this part of the list to this one name. I bind the second part of the list to a different name, and I bind the third part of the list to a different name. Okay? So that's where the whole pattern matching and decomposition thing really becomes interesting and fun, is that it allows you to take and not only say, does this structure match this pattern that I want to match, but also can I pluck out certain data so I can deal with that piece of data. Okay. So one last thing, there are a few common symbols you'll notice in almost every pattern matching implementation. I'm going to discuss a couple of them. Bear in mind, though, that even though these symbols are common, there may be some difference in the meaning associated with it in a particular language. So don't just look at it and say, oh, there's an underscore, so it means so and so. The underscore is almost, you'll see it everywhere, in pattern matching. The underscore is an interesting thing because it basically usually means there's a value there we don't want to bind. Like if I had a list of three items, right? I might have, my open list thing, then underscore, then concatenation operator, then underscore, then concatenation operator, then underscore. That basically means there's three things there. I don't care what they are. I just care if there's three things. Okay. Underscore is also interesting in that it can be bound to a single element or it can be bound to a set of elements. It's kind of like if you're familiar with regular expressions, like in globs and stuff like that. It's kind of a combination of a question mark and a star. Actually kind of serves both purposes. Okay. Square brackets, at least in my experience, you almost always see those with list. And again, when I say list, I'm talking about linked list. I think I've seen a couple different notations, like in like Haskell and places like that, where they do a slightly different thing as far as binding, but when they're constructing a list, it's almost always square brackets. The pipe symbol is usually associated with concatenation. Like I'm again, when I'm constructing a list, what I usually do is I concatenate together elements into the list. So you'll often see a notation like square bracket, item, pipe, rest of the items, square bracket. That's a common pattern match that you'll see. The colon and the double colon, I don't think that's common across all functional languages. I've seen it more in Haskell and in like Haskell derived languages, stuff derived from OCaml and stuff like that. Usually, almost always, again, you'll see the colon to specify a type. In almost every functional language I've dealt with, when there's types involved, it'll be value name colon type of value, like X colon integer or Y colon float, stuff like this. The double colon is used in some languages, like I say, languages derived from OCaml and stuff like this, to indicate concatenation, just like the pipe is used in other languages. It's saying I've got elements on the list and I want to indicate that they are separated by this is one element, double colon, here's the rest of the elements, that kind of thing. I'll give you some examples, so hopefully this will be a little bit clearer. The parentheses, again, that is an interesting thing because some functional languages, again, derived from OCaml and that family of languages, that standard ML family of languages, they don't bother with parentheses for argument list, which I know probably sounds really strange. Like I'm calling a function, call it F. What you'll see, and I'll show you, you'll see when I show you some F# stuff in just a minute here, you'll see that it will, it'll be like function name F space first argument space second argument. There's no parentheses there because they reserve the parentheses for tuples. So you'll often see that the parentheses are used for sometimes for pattern matching, sometimes for tuples, usually for tuples. It's another reason why you remember I was saying just earlier that the underscore kind of serves the same function as both a question mark and a star. There's a good reason they don't use a star for a wildcard in functional programming because star is used for multiplication. And so they use the underscore instead because that's not like overriding anything. Okay. I say I apologize. This is probably a little dense, but I will give you some examples of what I mean, and hopefully I'll make it a little clearer what we're talking about. Okay, so what I'm going to do is my first code example to kind of give you an idea what I mean with pattern matching is I'm going to just do a very trivial thing. I'm going to sum up a list. Some of you guys I would never do it this way. If I were writing production code, I'm going to do it recursively. Almost every functional language I've ever dealt with has a built-in like reduce or fold or function like this, where you can take and do basically a thing over a whole list to reduce it or sum it up to one thing. But in order to demonstrate what we're talking about when we're talking about like pattern matching, it's easier for me to do it this way. Okay, so a few points I want to make just to make sure we're all on the same page. First, and I know everybody's experience level, so if this seems remedial, I apologize, but I want to make sure that I say it so we're all on the same page. First, the first element of any list is commonly referred to as the head of the list. Next, the rest of the elements in the list are called the tail. And those are relative terms. Like if I have that list there, 1, 2, 3, 4, 5, right now the head is 1. But if I took and say, okay, got rid of 1, right? And then I consider 2, 3, 4, 5, and the head is 2. So it's not like the head is always going to be, it's just the first element in the list. It's not a specific element, okay? Another point to be aware of, there's always an implied empty list in any list. It's not necessary, you don't have to say there's an empty list there. But if you go through and do, like, for instance, you say, okay, pick off the head. Okay, here's 1. And then the tail is 2, 3, 4, 5. And they say, okay, now pick off the head of that list. That's 2. And the tail is 3, 4, 5. Eventually you can get to a point where, okay, I'm going to match, my list is going to be 5, and that's it. So I match that and say, okay, give me the head. And in that case, the tail will be an implied empty list. So, so this is important when you're doing recursion, okay? Any list also can be defined as a concatenation of the length of sublist. So effectively, a list 1, 2, 3, 4, 5 is the same thing as a list of 1 concatenated to a list of 2, concatenated to a list of 3, etc., etc. And this becomes really kind of important when we're doing pattern matches. Okay. All right. Enough of me just blathering on. Let's get an example up here. And since I'm glad to see there's a lot of Elixir fans, because I love Elixir. Let me see if I can get this over on the screen we're sharing here. Will it come over there? I'm on over here where I can show people. Huh. All right, I may have to share a different screen. Hold on a second. Let me share that. Okay, can you all see this replit I've got here? Excellent. Okay. So, and I know, apologies to those who don't know Elixir. I'll try to explain this as well as I can. But basically what I'm doing is I'm basically summing up this list, right? Now, Elixir, besides supporting pattern matching and decomposition, one of the nicest thing is they've made it to where it's pretty much everywhere. You don't just have to do it inside of a match statement or something like this. It's pretty much everywhere in Elixir's syntax. So I can do, if you'll notice here on line 5, I'm sorry, is that font big enough for everybody? I'm sorry, it just occurred to me. I should have asked. Can everybody see the font well enough?
That's fine.
Okay. I'm seeing 1 thumbs up anyway. Okay, cool. Okay, so if you look at line 5 here, I've defined some list as it takes an argument L, and in Elixir, for those of you who aren't familiar with it, if I put underscore in front of the argument name, that means I'm not going to use it in the body of the function, and don't warn me that I'm not using it in the body of the function. Okay, I'm only using this here to allow me to decompose it into a head and a tail, which in this case I'm calling H and tail, but that's basically what it's saying. It's saying head is the first element, tail is everything else. Okay. And this is a very common pattern. You'll see this all the time if you do recursive code. You'll do like a head element in an accumulator. And in this case, because Elixir is dynamically typed, I want to make sure I'm not doing it on something besides an integer. So I just check to make sure that the head is actually an integer. and then I recursively have some list call itself with the tail of the list. So the first time I do this, head will be bind to 1, tail will bind to 2, 3, 4, 5. Okay, and the second time I go through, head will be bound to 2, 3, 4, 5. I'm sorry, 2. Tail will be 3, 4, 5, and accumulator will be 1, because it's going to add whatever's head is plus accumulator, and down here I've got accumulator set to 0 initially, so it's going to be 1 plus 0, so it's 1. Okay, and then it goes ahead and recursively calls itself again and says, okay, now I take and add head to accumulator, so 1 plus 2, so now my accumulator value is 3, and I pass the tail, which in this case is 3, 4, 5. So it does that over and over again. I'm not going to go through every iteration, right? And eventually it'll come to a point where all that's left in there is an empty list. Remember I said that it's always an implied empty list in a list. Eventually it'll get to that point and it'll say, okay, all that's left is an empty list. I've recursed through this, and when I call some list again, all I'm getting is an empty list. At that point, I know, okay, it's time to stop because I'm done. I've got everything in there. I've gone through all the items in the list, so I stop. And at this point, I just return accumulator. And if I run this real quick, not that it's really any great shakes, but you'll see it says sum is 15. Yeah, big deal. Okay, so so I say that's if you have to do recursive programming, by the way, that's an important thing. You always want to make sure there's a base case where things terminate, because otherwise you will have a big problem. Okay, so if I go to here, now I'm that's Elixir, and Elixir is pretty cool. I like it pretty well. Let's look at it in F#. F# to me is a great language, and it's just a shame that Microsoft and editorial comment, sorry, it's just a shame that Microsoft is just they've done so badly by it, but I'll leave my editorial off. Okay, so here you'll notice, like, if we look at Elixir here, I don't have to tell it, hey, this is recursive. When I look at F#, I do have to tell it it's recursive, because F# does type inference. F# is strongly typed, but if I don't tell it the type of things, it infers what that type is. And without that recursive keyword there to tell it, hey, what I'm referring to in here, when I refer to some list, I'm referring to this again, right? Without the recursive keyword to tell it, the type inference will get all screwed up, okay? So this is basically telling F#, hey, this is a recursive function. Some list is a recursive function, right? So first it gets past this list, this 1, 2, 3, 4. And again, you'll notice that F#, instead of using commas to separate things, for whatever reason, they decided to use semicolons. I don't know why. I don't know what it was about commas that they didn't like. And I'm sure there's a very good reason for it, but they use semicolons instead. Okay. So I passed this list, and here L gets bound to number list in this call right here, right? So L up here is bound to number list, and accumulator is bound to 0. Okay. So then I'm sorry, got Elixir on the brain. F# then says, okay, does L look like head and tail? And remember I was saying earlier about, like, languages derived from OCaml, they would use the double colon as a concatenation operator versus the pipe. This is one of them cases. F# is derived from OCaml, which is derived from standard ML, and all of them, they use that double colon as a concatenation operator. Okay, so it's saying L matches this case where there's a head element and there's a tail, and what it does is not only does it match it, but it says, okay, decompose it into that. So now bind the first element, the 1 here on the first pass, to H, and then bind the rest, 2, 3, 4, 5, to tail, and then the same thing, call some list again with the tail and add H to the accumulator. Okay, and the very same thing, just like I did with Elixir. When I get down to an empty list, then I toss back the total accumulation. And if I run this, you'll also see I should get a sum is 15 here in just a second. If I don't get a sum is 15, I'm going to be disappointed. There we go. Okay. So as I said, this again is one of them things where it's interesting to me because F# does not use those parentheses like Elixir does. And we're going to look at Scala in just a second. And Scala uses those parentheses. Okay. And it doesn't use a comma to separate arguments either. It uses spaces. So this is effectively here, number list 0. It's basically matching here this. It's the same idea. It's just like I say, it's just something that I guess my understanding is, and I'm sure there's probably going to be some folks in here who know math far better than I do. But I guess in mathematics, if you write a function name followed by things separated by spaces, in that case, what they interpret it as is here's the function name, here are the arguments. So I guess that's closer to what math actually looks like when they do that kind of thing. I like I say, my math is kind of rusty. So, okay. Let's look at Scala real quick. Now, Scala is giving me some problems. Hopefully it won't give me problems again. And again, this is one of the things I love about functional programming. This is so compact. You know, all three of these cases, look how many lines we're dealing with. I mean, of course, it's a very simple example, but these are really compact. Okay, in Scala now, I've got my function against some list, right? And I can't do type inference on this. Again, Scala is strongly typed like F#, but this time it doesn't let me do type inference. I have to specify types. Okay, so I got to tell it I've got an argument L, and that's a list of integers. And again, as I was saying, that colon there is pretty commonly used in most functional programming to say, okay, the part in front here, the L, that's the name of the value, and the part behind the colon is the type of the value. Okay. So some list is going to take an L, or a list of ints called L, an integer called accumulator, and it's going to return an integer. This is what this part is here. Now, Scala also took some stuff from like C and C++ and all those other algol family languages. And so they also use curly braces, which is something that I honestly, if I never saw curly braces in a language again, I wouldn't be exactly heartbroken, but it is what it is, right? So in Scala, what we do is like in F#, we say, okay, match L with whatever. In Scala, we say L matches something. And then we say, what cases are there? Okay. And again, same thing. I have a case where I've got a list where I've got a head and a tail. Then what I want to do is I want to recursively call some list with the tail and the head plus the accumulator. And this is the case, unlike F# and Elixir, this is the empty list in Scala. List with parentheses. Okay. All right. So, and you'll notice down here that unlike F# and unlike Elixir, I have to tell it the type of number list. So I say it's a type of integer list here. And then I say it's a list of 1, 2, 3, 4, 5. And you'll notice again that Scala uses the parentheses to pass arguments. So this is slightly different than F# and other stuff. But ultimately, I run my sum list, I get my sum back, and then I print it. And so let's see if this will print for me. It should. In just a second, I'm going to show you Haskell. Haskell to me is even more. It's one of the things I've looked at in the past and thought to myself, well, one of these days I'm going to wrap my head around that. But it's something else to me. I don't know. Maybe you guys will find it like perfectly clear and not at all surprising, but to me, it surprises me a bit. Come on, run. There it is. Okay, cool. So we have our sum. Okay. I tell you one thing, in putting this presentation together, I have been firing up some brain cells that I didn't have to fire up for a while. So it's kind of a good thing. It reminds me of some of these things I'd done and forgotten. So okay, let's look at Haskell now real quick. Now, F#, Scala, Haskell, they're all strongly typed. Haskell's type system is even more extensive than what you got in Scala and F#. The type system in Haskell is actually Turing complete. You could actually like code in the type system in Haskell. I understand. Somebody might know better than I do and correct me if I'm wrong, but you know, the best way to find out you're wrong about something is to say something to a bunch of developers. they'll be oh no, Onorio, it's this. So that's part of the reason I like doing these presentations, because I learn, you know. But anyway, the type system in Haskell is such that I need to tell it before I even have some list. What is it? It doesn't infer it. I got to tell it, okay, some list is a function, and the double colon means here's the definition. It's a function. We'll take this is a list of integers, right? The square brackets tell me it's a list, and also an integer parameter, and it's going to return an integer. Okay. So now in Haskell, what you do is, rather than having like a body of a function, what you do is you define for each argument list, what does it do? Okay. So when some list gets a list, and I don't know why they don't use square brackets here. It threw me when I was playing around with this the other day. It's like, why isn't this working? I had to ask one of the Haskell folks, oh, well, you don't use square brackets there. Oh, okay. Because I wasn't finding that in their documentation. Anyway, they use parentheses there to indicate a list. And rather than, you know, and again, I think sometimes language designers are a little perverse that they don't want to use common standards. They don't use a double colon, which I guess makes sense, because they're using it up here to define what some list is. They use a single colon rather than a pipe or something like that to indicate, you know, concatenation. And so again, when it gets this list, this number list, it says, okay, here's the head, it's 1. Tail gets bound to 2, 3, 4, 5. And accumulator, it will get bound to, because the call here is some list, it gets bound to 0, right? And since it matches this pattern, it matches the pattern of I've got a head and I've got a tail. It will say, okay, then what I'm going to do is I'm going to call some list with that tail and the head added to the accumulator, right? And it keeps doing that recursively until it gets, you know, to the 5 here. And the next thing that'll go in, it'll be like, okay, the next pass, the tail will be the empty list. And so when it goes to match, it'll say, okay, I got the empty list now. So I can hand back the accumulator. Oh, that is a good point I nearly forgot to say, and I'm sorry about that. When you're doing these pattern matches, be careful, because most functional languages will tell you if you do the pattern matches in the wrong order, but if you do them in the wrong order, you'll run into problems. Okay, like if I did the match on the empty list first and then the head tail, this would not work correctly. What would happen is the last item in the list would not get added in correctly, if I remember right. I do remember, like, in most functional languages will tell you if you ever put a case in there where it's like, hey, this is never going to match, because they can check all the matches and make sure you've covered all the possibilities. So just be real careful about the order you put the pattern matches in. Okay. In Scala here, you'll notice I put my head tail first, and then I put my empty list. In F#, same thing, head tail first, empty list. And even in Elixir, it goes top to bottom. So head tail first, then empty list. Okay, very important. You always real careful about the order you show things in. Okay. All right, so let me switch back to this screen for sharing. A minute. Come on. Where's my mouse? There it is. Okay. And it would be this one. Okay, so that's all the first example. Okay. So now we're going to do, because I want to show you a little something where you use that underscore, because in the particular example I gave you before, the underscore really doesn't play into it. It's binding head and tail, or it's binding an empty list. The underscore doesn't come into it so much. So I'm going to show you some examples of doing it with the underscore to show you something here. So in this example, what I'm going to do is I just have a list of 10 numbers. I just pick 10 at random. I'm going to discard the first 3 just to show you what it looks like with the underscore. And then I'm going to compute the average of the remaining numbers in the list, the tail of the list, if I get rid of the first 3. Okay. So I'm going to go ahead and switch the share back. Un momento. It's going to be you, right? Yeah. Okay. Get rid of some of these so I can kind of see what I'm doing. So again, these ideas are pretty common across. Oh, come on. Give me a little more room, guys. These ideas are pretty common across various functional languages. Okay. But each language implements them a little differently, and that's what's kind of interesting, right? Like, for instance, Elixir, as those of you who know Elixir know, you can have private functions inside of a module. It's kind of like the same idea as you'll have with like, you know, with OOP, we have something that's not visible outside of the class, but this is a module, not a class. So it's analogous, but it's not the same. Okay. So I have a couple of private functions here. First, I want to check that my list is okay in the sense that it's got a length of 10, and I want to check again, because Elixir is not strongly typed, it's dynamically typed. I want to make sure that all the elements in the list are integers, which I will do by doing a reduce. A reduce, without getting too far into the weeds, is basically take and start with an initial value, and then apply an operation with the first value in the list plus that initial value, and hold that result, and then do that result with the next element in the list. So in other words, what I say here is take the list, which is going to be this, right? Initially assume true, then take and take the true I'm initially assuming, and it logically and it with is integer, that element. So as long as this integer is true, it'll return true. The first time integer is false, because I'm logically ending it, it's going to return a false. So that way I can be sure that all 10 elements in the list are integers. Okay. Now the discard first 3 is where it's really interesting. This pattern here is saying, okay, I've got a list. You'll notice the square brackets, right? And the first 3 elements of that list, I don't care about them. I don't care what they are. I just know, I just want those first 3 elements identified just so I can remove them, basically. When I'm decomposing those first 3 elements in these little underscores, which I can't really reference anywhere else. And then the rest of it, the other 7 things become the tail. And what I'm doing is I'm saying, okay, take those first 3, get rid of them effectively, because I'm not doing anything with them. And by the way, if I decided to do like this, for whatever reason, I wanted to do that way, because maybe I want something more descriptive, that'd be perfectly fine. As long as it starts with an underscore, you're good. Okay, but I'm not going to do that. So effectively what I'm saying is take the first 3 elements, discard them, and then whatever's left, that's the tail of it. Okay. So then I have a function to do my average, right? I sum up my list, which again, I wouldn't normally write like a sum via recursion like I showed you in that example, because there's better ways to do it. There's a built-in enum sum in Elixir, and I would much rather do that, because I don't know about you guys, but writing recursive code is always kind of scary to me. So I would much rather like do something that's in the library and I don't have to worry about that. So I will take and say, okay, what's the sum of the list? And I already know for sure by the time I've gotten to this average that I've got a list of 10 elements and I know for sure they're all integers, so I'm safe to do a sum. And then I do what's the length of the list, and then I do the sum divided by the length, which is the name, is basically an average. Okay. So down here in def main, I initialize the list of 10 numbers, and then I check it to make sure it's okay. Customarily in Elixir, what I would do if it weren't okay, like the else here, well, I did that. I forgot I did that. In Elixir, the convention is to return a tuple. This is an interesting thing. A lot of functional languages support what they call an option type. This is Elixir and Erlang's basically implementation of the idea of an option type. This is a far better approach to returning nulls. Like in a lot of OOP languages, a lot of imperative languages, they return nulls, and then because it's the only value that's guaranteed not to be misinterpreted. Okay, but anyway, be that as it may. I'm sorry. So I discard the first three numbers from the list, right? And then I pass that list into average. And then I pass that average number because I want an integer. I want to be able to see an integer when I'm done. I pass that into ceiling. Okay. And then I output averages, whatever the calculated average is. And I finally return a tuple. I'm sorry, I didn't talk about this in terms of Elixir, but since there's so many people who know Elixir, I'll skate on this for a second. Curly brace is a tuple, and it can have any number of elements. In this case, what they usually do, convention in Elixir, is to have an okay or an error atom as the first thing, and then if you have an okay, then you return the value and you pattern match. Strangely enough, love pattern matching. You pattern match on okay, and then you just bind the calculated average or whatever it is to your answer. Okay. So in this case, because I know I'm not going to get the error, I'm not going to buy. Well, you know what? Let's try it and see what happens if I take out. I should get that error with my error message. There we go. Not a list of 10 numbers. Okay, cool. So let me put the 120 back. One of the nice things about having this REPL is stop that. Rerun it. Now I should get averages like 78. Yeah. Huh. I remember well. So, so like I say, this is a nice thing about pattern matching. I don't care what these first three values are, and it's hard for me to think of a use case where I'd say, okay, here's a list of numbers and discard the first three. It's nothing that just comes to my mind. It feels real arbitrary. But if I had that kind of use case, I don't care what those three numbers are. I'm just discarding them. And whatever they are, they don't matter. What you'll often see, and I didn't do it in this case, is you'll often see something like where I will do like something like that. And that what that says is, okay, if I get if result is a tuple which contains okay in value, then it just binds value and I do something with it down. If it comes back with error message, well, it's going to say I can't bind this, and it's going to stop me right there. That's very common to see that kind of thing in Elixir and other functional languages too. Okay, so let's one last thing. Let's look at F# real quick. How we do this in F#. F# is a little more interesting, I gotta say. And partly because I had to reach back for some old brain cells to remember how to do this. Okay. So for one thing, there is a way to do optional types in F#. I just don't remember it. So if you're looking at this and saying, gosh, I thought he said he would, he would hand back an optional type. Yes, I could have. I just don't remember how to do it, and it wasn't that important for the idea of showing pattern matching. Okay. But in F sharp, sometimes, even though it will do type inference, sometimes you need to tell it types because it can't infer what the type is from what you're telling it. Okay. So in this case, this is telling it specifically that list here that I'm binding to is a list of integers. Okay. And that it's just because it needs a little help in figuring out, the type inference stuff. Okay. And it's the same syntax as before. It's match list with, in this case, same thing, underscore, but then the concatenation is double colon, not type, underscore, double colon, underscore, double colon, tail, and then I hand back tail. And if for some reason I get something besides something that matches 3 elements and then a tail, so in other words, at least a list of 4, if I get something that matches something besides that, then I'm gonna hand back an empty list. Like say, what really should happen is I should have an optional type where I should say, okay, here's the optional type and here's tail. This is okay. And on the other branch, say there's no value here. But like I say, I got a little lazy, honestly. Okay. So on average, then I define also, and you'll notice I don't have an is okay function like I did with Elixir. I don't have like a list is okay because I don't need it. Because F sharp is statically typed, I don't need to check that all the elements in it are integers. So it's like, okay, cool. I know they're integers because I declared it. They're integers. And if I handed it something besides a list of integers, the compiler would complain and say, hey, wait, you can't do that. I'm looking for a list of integers. Okay. So the average is the same thing. It's basically I figure out the sum of the list, the length of the list, and the list sum divided by length. Okay. And I do then calculate average, which takes the list, and then I do, why did I bother with this list? Okay, I don't need that anymore. Huh. I'm sorry. I forgot to remove that. My bad. Oh, I was checking the length of the list. Okay, that's what it was. I wasn't checking the type. I was checking the length. See, I apologize. I forgot that. Okay, so assuming the list is okay, assuming we've got 10 elements, then I discard the first 3. And you'll notice that here, F sharp uses that pipe forward operator that we like so much in Elixir. Elixir borrowed the pipe forward from F sharp. I don't know, I have never been able to find out if F sharp borrowed it from someplace else earlier, like OCaml or Standard ML or something like that. I have the feeling they did because I think I've seen it in other places. I think I've seen it like in Haskell and places like that. That were invented around this, or actually Haskell was invented before F sharp, if I remember right. But honestly, I think the pipe forward, if you've never used it in a functional language, write it for yourself as a function in a functional language. It makes certain things so much clearer, so much easier to understand. It's not even funny. Okay. So I discard the first 3 elements and I hand that list directly into average, and average then calculates that value, right? So I go ahead and I say, okay, here's my number list. And again, remember with F sharp, I put semicolons rather than commas for whatever reason. One point I want to make on this too before it gets away from me. In F sharp, because things are strongly typed, your if and your else branch both have to return the same type. You can't have like an if branch, and you have to have an else branch. I believe. Pretty sure in F sharp, you have to have an else branch. And they got to both return the same type. So in this case, I'm returning an integer here. So this automatically becomes an integer over here. Okay. This kind of gets interesting. And because it is strongly typed, and this doesn't come up in Elixir, it comes up with F sharp and like Haskell and languages like that are strongly typed. What do you return if there's no reasonable return value? Like for instance, down here I got a print, right? What do I return from a print? I don't return anything because print just puts something out to the console and there's not really anything to return. In that case, what those languages that are strongly typed functional languages use a special type called unit. Unit is just basically saying you know, there's a type here, and the only type it is itself. That's all. It's just the unit type. It's effectively saying there's nothing here to hand back. I'm running this function just for side effects. There's no reasonable value to return. So I'm going to hand you back to the unit because I've got to return some type. Okay, that's probably not the best explanation. I apologize. So let me show you what happens here when I run this. I should get 78 here also. I think might come back with 77. I can't remember. Come on. Oh, 77. Okay, there we go. Okay. So let me go back to my slide deck. Okay. So honestly, that's all I got to say. There's a lot more you can do with pattern matching. Just show you something that might be a little interesting to some of you. I did do this in Haskell because I'm sorry, Idris, because I find Idris incredibly interesting as a language. Let me see if I can bring it up here real quick. I'm going to stop sharing for a minute because I want to grab this one thing so I can show it to you. Okay. Let me put this over here. Resume sharing. But I want to share this instead. There we go. Idris is really interesting in that it allows what's called dependent types. Now, I'm sure a lot of you have seen things like where you and you're not going to see this as an example, but this is part of what really the appeal of Idris is. I have a vector, right? Effectively an array of numbers, right? And I have an operation to say, shove two arrays into a bigger array. I should be able to say, if array A is 100 members and array B is 100 members, then my result should be 200 members. I can't do that normally in normal functional languages even. Idris allows you to specify, hey, if I've got a language, or I'm sorry, an array of 100 here and an array of 100 here, then I should get back an array of 200. And so it gives you even more checking on your code to make sure your code is right. Let me show you what I've got here. Let me see, it was yeah, it was and let me Visual Studio Code up here for a second. Hold on, I'm sorry. This is I apologize. This is something that I know if I'd have time to do or not. So it's kind of like a last minute addition, and I apologize. Okay. So Idris now even a little different from Haskell. It says, okay, here's the function sum list, right? And the definition of sum list is that it will take a list of integers, and notice, unlike Haskell, they don't have like sorry, get rid of that. They don't have like, you know, parentheses around it, but it does use that arrow notation. Like, okay, this is my first parameter, this is my second parameter, this is my return type, right? Like Haskell, though, they do have a thing where they will do that pattern matching thing, where it's like, okay, if some list is called with an argument that conforms to the first argument, has a list with a head and a tail, and the second argument is an accumulator. In other words, the first argument is a list of int, and the second argument is an int, then do this. Call some list on the tail and the head plus the accumulator. Okay. And finally, as with everything else, you're going to go through the whole list and you're going to get to an empty list. And when you get to the empty list, okay, now all you got to do is take the accumulator and just return it. That's all you got to do. Okay. And so here in Idris, you've got to declare everything. You've got to declare all the types. So your number list, you're telling it it's a list of ints, and then I initialize it. And again, unlike F#, comma, comma, comma. And then finally, I have a variable called sum that's going to get an int. And the definition of sum is the result of calling some list with number list and 0. Okay. Let me shrink that for a second. So if I do right here, it's already run it. So I do sum 15. I don't know if you guys, I hope you can see that. I hope the font's big enough. So like I say, I just find it very interesting. It's an interesting exercise to look at different functional languages and see, you know, they all have the pattern matching. It's very cool. I apologize. I was going to work up a Clojure example, but I just didn't get around to it, and I apologize for that because Clojure has some very cool stuff with pattern matching. They all have the pattern matching and have the decomposition. To me, that makes the code a lot easier to read and a lot quicker, a lot more terse, which is a good thing, I think. As I said, that's pretty much it for this presentation. So, and that's not how you exit Idris. Okay, so let me go ahead and close that. And let me stop sharing my screen. Pause share. Do I have a stop share? Oh, there it is. Okay. So and I'm going to move this screen over here where my camera is, so I won't be looking at off in the other direction. So that's pretty much it. Did anybody have any questions about what we talked about? Any observations? Any comments? I'm open to anything. Don't be shy.
Oh, hey, Onorio, I just want to say thanks. It was a great presentation and interesting to get exposed to a number of different functional languages. Elixir is like my first and only at this point, so pretty cool to see recursion in the other languages and see how that's done. And yeah, thanks for that. I appreciate that exposure.
Oh, you're welcome. I was working with some junior developers, and one of them asked me about like doing something in F#, and they wanted me to show them how to do it with recursion. And I got to a point, I was playing with F# for quite a while, and I got to a point where I couldn't even remember how to do things with recursion anymore, because it's just like, given the choice between recursion, like the sum I showed you, given the choice between doing like that recursive version of the sum versus doing like enum.sum, I'd pick enum.sum any day of the week because it's a lot less error prone. Writing, I don't know about you, but writing recursive code for me is just like, wow, that's just like a good way to put my foot right into a bear trap.
No, definitely go for enum first. I mean, that makes a lot of sense, and use the code that's tried and true rather than, building your own. So yeah, it makes a ton of sense to do that versus, writing something recursively if you don't have to.
Exactly. Don't be shy, folks.
Thank you, Onorio. I'm not shy at all, but
Okay.
thanks for the presentation. It was enlightening.
Cool. I will share with Mike the link to those REPLs because it's all public. So if you guys care to look at it afterwards and say, okay, how did Onorio do the pattern matching here? How did Onorio do the pattern matching there? I'd be happy to share it. So
I'll post it.
For yourselves.
I'll post it in the group alongside your LinkedIn profile as well. If anyone wants to find you, obviously, and yeah, any questions do pop up after this. I'll post this on YouTube as well, so the wider web can tap into it if they need to as well.
Cool. Yeah, like I say, to me, and I I don't mean to imply, because I said to somebody once, you should learn at least 2 languages, but it's that second language that's really hard to learn. And 2, when you cross paradigms, when you cross like OOP to functional programming, it took me a long time to wrap my head around a lot of the functional programming ideas. But once you do that, once you make that leap and you start looking at other languages, you'll start to spot that a lot of things are the same, they're just expressed differently. A lot of the ideas, like I say, like a list is pretty much everywhere in functional programming, and it's in imperative programming too. But it's just expressed by different notation. It's interesting to me to see that Microsoft and C# has taken features from F# and like backported them to C#, which is a shame because I think they should be directing people to F#. But again, more editorial comments from Onorio. But it's really interesting to see that that they've done that. They said, okay, this pattern matching is such a cool feature, we're going to take it back to C#. And it is. It's just really a neat way to write code and to compose code and stuff like this. And very powerful. You can do a lot of powerful things with just a little bit of code with pattern matching. And like I say, the nice thing is in strongly typed languages, and when Elixir gets gradually typed, hopefully it'll work there too. Because it can see your patterns, it can tell you, hey, you haven't covered every last case with this. Like you noticed on the patterns I was showing you, there was like head and tail and then empty list, right? If there were like a third possibility, if there were head and some element and tail, and I hadn't covered that, it would tell me, hey, you haven't covered this. This is the possible case that you need to cover, which is really cool because as a developer, I forget things all the time. So no more questions or comments or anything. Honestly, I love talking shop.
Hey, just a quick question on lists. Outside of Elixir, I'm assuming they're linked lists and they operate more efficiently by prepending to the list versus appending to the list. Is that something you've
100% correct.
Yeah.
Yes.
Okay.
100% correct. I don't know if you know big O notation. A list is big O of N.
Yep.
Putting at the front is always much faster than putting at the end. And so that you'll see I think there's even stuff in the standard library to take and reverse a list real easily, because what you usually want to do is put everything at the front. And if you need, okay, this should actually be at the end. What they'll usually do is they'll put it at the end of the list. There's even a pattern match you can do. There's so much cool pattern matching stuff you can do with Elixir, like you can do a pattern match on the end of the list, like the last element of the list. I think I may be remembering wrong. I'd have to look, but the pattern matching is just very cool stuff. There's a guy named Chris Keel who is working on a library called Matcha that has some really neat stuff. It was actually tapping into the matching features that are present in Erlang, which underlie what Elixir has, and just some really cool ideas where you could store a match and just use that match as if it were a function, and treat it as a function, pass it around, and use stuff like that. And I don't know where Match is these days, but he has some really neat stuff going there. So
Brilliant. Excellent. A lot of bang for a buck. Oh, we've got a question come in via. Oh no, okay.
I have a question. I'm just wondering we discussed specific feature of pattern matching, but I'm just wondering what's the general jig in functional languages such as Haskell, I guess, and F#2 profile. If you because with the functional code is everything is sort of a formula, and it's kind of hard to actually step-by-step debug. I'm just wondering, like, what's your perspective on profiling
That's
and
an
kind of
excellent
getting
question.
the most? Yeah.
F#, because of the fact that Microsoft built it, they've got pretty decent tooling for step through the debugger. Elixir's getting a better story with that. They're getting to where you can dump out values at arbitrary points in a calculation. part of the issue with debugging, and honestly, I'm not 100% on Haskell because I don't use it on a regular basis. I just put it in as an example. Part of the issue with debugging is, especially if you're dealing with like Elixir, you've got multiple processes running, and so you run into an issue where one process running, you can have multiple processes running, and if one process gets done first, sometimes it affects the calculation. Like if I were to take and you got to be careful when you're building things in Elixir to make sure that you don't have that kind of dependency. Like, hey, A has got to finish before B, or it don't work right. That's a big no-no in Elixir, and that makes it hard to debug too. Because if you have something that where A has got to finish before B is done, otherwise you get an error, then part of the time you'll get an error because B will finish first, and it'll be really hard to track down. And part of the time you won't get the error, it'll be a real intermittent error and really hard to debug because, hey, here's A and it's done and it's fine. So that's kind of down to, you kind of need to, well, I'm sorry, that's a specific example, and you were asking about debugging. I apologize. Mostly with languages like Haskell and stuff like that, it's pretty much down to a lot of times just basically dump out messages, do tracing like we used to do back in the old days.
It makes sense. Yeah, that's pretty much it. Because that's what I've been fighting with. In TypeScript there are a lot of functional code and some projects and large blocks, and you have to basically read through that and compile it in your head, and it's kind of really taxing. So yeah, thanks for the
Yeah, I remember seeing Bruce Tate talk once, and Bruce did a book called 7 Languages in 7 Weeks, and he decided as the exercise he was doing, because you could just what I just showed you is very trivial stuff, right? Sum up a list, who cares, right? He decided for his exercise, for his demonstration of these 7 languages, that what he would do is a Sudoku solver. Oh, man, that's ambitious. And but he said the thing that impressed him about Haskell was it was hard to get it right, but once you got it right, you were almost certain to have the right code. He said it was a lot trickier to get it right than like other languages because it's kind of like there's not a great debugger story, at least as far as I know of. Maybe things have changed since he wrote that book, and that makes it a lot harder to get it right in the first place. But once you do get it right, it's usually right, so you don't have to worry about funny errors that dangling pointers, nonsense like this. So
Good stuff.
thank you.
Excellent. Yeah, got four or five for the price of one with the languages today. I wasn't expecting that. That was a real nice real nice surprise. Thank you very much. Brilliant.
Yeah, I find it really interesting to compare across languages. What is so and so's implementation of this idea, because like I say, then you start to realize it doesn't have to use this. It could use this instead, and it's perfectly fine. So anyway, I'm sorry I'm repeating myself. Thank you so much for asking me to speak, and I hope you all got something of value from my talk. So
pleasure's all ours. Thank you very much. And as I say, I'll send me over anything that you'd like me to share, and I'll post it directly in the group, and people can pick that up, and I'll put your LinkedIn profile in there as well, and people can find you and speak to you about whatever they need to do.
Well,
awesome.
Yeah, well, and everybody keep pushing functional programming. Eventually we're going to make people realize that
Exactly.
It's a much superior approach to other approaches. We're going to get there eventually. It took a while, and people don't believe me, but it took a while for OOP to catch on.
Yeah.
I remember when OOP was like, are you sure you want to use OOP? And now it's like it's assumed everyone's going to use OOP. So it's going to be the same thing with functional programming. It'll just take us a while.
Yeah. I've got a business banked on it, so I'm with you guys. Don't worry.
I have no desire to go back to OOP whatsoever.
I don't blame you. Do
Totally
not blame
sold
you a
on
bit.
functional. Yeah.
Okay,
Awesome.
well,
Wicked.
I guess that's it.
Perfect.
Have a good night, everyone.
Yeah. Take care. Thank you for coming out.
Thanks
Bye.
again. Take care, guys.